Hi everybody and welcome. Today we're going to be talking about solving rational equations. So your goal after watching this video will be able to solve a rational equation for the unknown quantity. So for example, if there's a single x term in a rational equation, then you can go through and solve for x. We want to actually get numbers for our answers today. That's our goal. So with that being said, most important thing that we're going to be dealing with today is least common denominators. And what an LCD, or least common denominator, is the smallest number that can be used for the denominator of two or more fractions. And what we're going to see is, let's say we have three terms, we have three denominators. We're going to have to find the LCD for all three of these things. The way that we do this is we still break them down into their individual parts. So x plus 3 is still just x plus 3. 6 we break down into 2 times 3, and then 18 we can break down into 2 times 3 times 3. And just like we did before, we start with one of these, and then we add on any or all unique parts thereafter. So let's say we'll start with the bottom one this time. So we have 2 times 3 times 3. If we look at our next row, nothing to add here. We already have 2 times 3 represented. But on our first row here, we do need to add in x plus 3 because we don't see that anywhere. So our LCD in this case is 2 times 3 times 3 times x plus 3, or we can simplify this out to say actually 18 times x plus 3 is our LCD. We would use this to convert all of our fractions to having that LCD, or there's another trick that I'll show you below that might save you a little bit of time going through. So when we have something like this, just like we were talking about above, start off with your two denominators. So we have x minus 3 and 2x plus 3. So we can't factor these out any further. So when we go to find our LCD, there's actually going to be x minus 3. And then we also have to take any unique terms from 2x plus 3, which that is not included, so it is all in there. So our LCD here is x minus 3 times 2x plus 3. When we go to solve now, if we look and we rewrite our original, we can actually multiply by the LCD. So if we multiply each side by the LCD on top, we're going to save ourselves some time, and I'll show you how. So again, do it on one side. I don't know why this select all button keeps coming up for me. I'm sorry about that, everybody. So we do that on one side and keep working through. What we can see is that we are allowed to simplify or cancel out some terms. So we have x minus 3 on the bottom, x minus 3 on the top, so those cancel. 2x plus 3 on the bottom, 2x plus 3 on the top, so those cancel. And what that leaves us with is 5 times 2x plus 3 on the left, and then 12 times x minus 3 on the right. So again, we multiply both sides by x minus 3 times 2x plus 3. We do it on both sides so we keep balance. And then that allows us to basically cancel our denominators here. And what we're left over with is how we're going to solve the equation. So now we can distribute in on both sides. So we'll have 10x plus 15 equals 12x minus 36. We can now subtract 10x from both sides, and then add 36 to both sides. And then finally, we can go through and divide by 2. So we'll get x equals 51 over 2, or 25 and a half. And we're almost done. We are actually not allowed to just stop right here. We do need to plug back in and check. The reason why is because we can't have 0 in the denominator. So we can't have If that's the case, it would be called an extraneous solution. So we have to make sure we don't have any extraneous solutions. We need to make sure that this 25.5 works, that we're not zeroing out anywhere. So we go back to our original equation right here, and we plug in for x. So we can go through and plug in 25.5, 25.5, and again, we really need to make sure we don't have any denominators of 0. So we're left with 5 over 22.5 equals 12 over 51 plus 3, or 5 over 22.5 equals 12 over 54. And let's check this. So when maybe we can make these into decimals to make our lives a little bit easier, save a couple steps here. So this would be 0.2 repeating on the left side, and then 12 over 54 is also 0.2 repeating. So that works, no extraneous solutions, but you can say with certainty that x equals 25.5. So checking your answers is actually not optional. So it's not like, oh, just to be sure, I want to, get some extra points here. No, you actually lose points if you do not check your answers. So we have to make sure that after we solve, we get that final answer, we are plugging it back in, and we are making sure that we do not have any extraneous solutions. A second thing to note here,